answer key. So our test is when? Wednesday. I'll be around tomorrow after school if you have any questions, and I'll be open tomorrow during Flex if you have any questions. A football player of mass 82 kilograms is running due north. You know what? I mentally, Tyson, underlined the word north, and I've just decided I think north is going to be positive because I see a direction. He collides with another player running south. Yep, you know what? I'm going to make that 8.1 negative. I put a big negative in front of it. And I decided to call this football player mass A, and the other player is going to be mass B. There's my high-tech system. After the collision, after the what? This is a job for conservation of momentum. So I'm going to start out by writing the sum of all the momentum before the collision has to equal the sum of all the momentum after the collision. Before the collision, what's moving? I think I have mass A, velocity A initial, and mass B, velocity B initial. That equal sign, that's the collision. Or as I often say, wham, they collide. Okay? After the collision, I think stick together, so it's going to be MA plus MB, V final. What do they want me to find? Looks like they want me to find V final. By the way, as far as I'm concerned, I can give you VB initial and V final and ask you to find VA initial. How would you get that by itself? Minus this over, divide by MA. How would you get this by itself? Minus that over, divide by MB. I think we're at a stage where it's fair game, Paige, for me to ask you to get any of the velocities by themselves. If you're really having trouble rewriting these, I guess you can stick in the numbers and just solve it, but let's learn to rewrite these. So I think I'm going to get this. V final is going to be MAVA initial plus MBVB initial all over the mass of them both because they stuck together. It's going to be 82 times 7.5 plus, Raphael, that's a 7, 65 times negative 8.1 all over 82 plus 65. I have no idea what the answer is. (82 times 7.5 plus 65 times negative 8.1). Close off the top, divided by bracket 82 plus 65. Where did I make a typo? 85 instead of 82, Mr. Dewick. Times 7.5, 65 times negative 8.1. Do y'all get 0.602? Direction. I got a positive. What did I say was positive in my specific? It looks like the first football player won the collision, pushing the second football player backwards. What if I had got exactly 0 here? Well, that would mean they both just came to a stop. And you see that sometimes happen in football as well. They run into each other and they just both come to a stop. They had equal momentum. Could happen. If you got that 4 out of 4, otherwise I would probably do something like this. Half mark for that, 1 mark for that, 1 mark for that, half mark for the numbers, 1 mark for the answer. Yeah, it's out of 3, Mr. Dewick. So I guess I got to change all these to little half marks as well. If you missed the negative, you would have got 7.77, and I probably would have given you 2 out of 3, but I would have thought bad thoughts about you because I've ranted about paying attention to vectors and direction. Number 2, just reading this, I only see one mass. Alex, I think this is going to be an impulse question. I don't see a collision. Okay? In fact, it wants the impulse on the ball, magnitude and direction. The first thing that I did was that. I see an initial velocity and a final velocity. It's a little tricky because the meters per second is on the next page, next line, but definitely that's a velocity. But I also, here's a trigger word, folks. I saw the word rebounds. What does the word rebound mean? It means the ball changed what? Direction. So I better let one way be and one way be. I'm going to let, I think, up be positive and down be negative because that just makes more sense to me. You could have done it the other way around. I think I'm going to find the impulse by going mv final minus mv initial. And Paige, you're right. I should also have said, nice try, Duick, 0.052 kilograms. So I'm going to get an impulse. What's another word for impulse or another phrase for impulse? Change in momentum, which is not just change in momentum. Means you have two different momentums, final minus initial. 0.052, positive 6.2, minus 0.052, negative 8.2. I'm going to get a minus, which is a plus, which makes sense because this ball had to undergo a pretty big change in momentum. It first of all had to come to a stop, and it had to get pushed up. Those are both in the same direction. 0.052 times 6.2 minus 0.052 times negative 8.2. Do you get 0.749? Kilogram meters per second. Or you could have said Newton seconds. If you got that, 2 out of 2. Otherwise, I would give you a half mark if I saw that. I would give you probably 1 mark for the numbers and a half mark for the answer. Probably give you you know what? I'd give you a half mark for this. And if I saw the negative somewhere, I would give you a half mark if you had recognized there was a change in direction. There is, ready, Tice? There is going to be a change in direction question like this on your test. And I'll even be more specific. It's going to be one of 2 possibilities: dropping something on the floor and having it bounce off, or throwing something against a wall and having it bounce off. But there's going to be a bouncing off, rebounds, change in direction question. Okay? What's the average force of impact? What did I find in part A? I could probably find force by going MA, but if I just found impulse, maybe I can find it quicker by using the impulse equation. I think force is also impulse over time. It's going to be 0.749, I'm using my answer button, divided by 0.15. Divided by 0.15. So I'm using my answer button. Did y'all get almost exactly 5 newtons, 4.99 newtons? Is that right? I would probably give you 1 mark if I saw that, half mark for the numbers, half mark for the answer. Some of you have turned the page and that's fine, but just before you do, or just look up, on your test, I think I gave you a question like this, but I didn't ask part A, I just asked part B. And I expect you to clue in, to find the force, I don't have an acceleration. I can either find the impulse to find the force, or I'll give you full credit if you choose to find the acceleration and go F equals what? There's 2 different ways of getting there. The impulse equation, it's not really something new. It's a Swiss Army knife shortcut that can be used to save yourself a couple of lines. But I would have no problem just asking part B without walking you through, you'll need to find part A first if you want to do this in the shortest way possible. Oh, sure, something like number 3. I knew I had done one like that. They want me to find the average force. There is enough information that you could find A and go F equals MA. But what I would probably do is I would probably go force times time equals MV final minus mv initial. I would probably go impulse equals impulse. By the way, you could also go like this. F equals what? A equals VF minus VI over T, and then stick that into there. I'll give you full credit for that. So if you're a little shaky, or if you're doing an impulse question and you're saying, Hannah, I'm more comfortable doing this with forces, I'll go ahead. As long as you can get it right, I don't care how you do it. I'd like you to do it the shortest way possible, but I'm not going to make you do it the shortest way possible. The force is going to be 1,225 minus 1,200 times 12 divided by 8. Bracket 1,200 times 25 minus 1,200 times 12, close off, divided by 8. I get 1,950 newtons. Is that right? Direction. Oh, they just wanted the magnitude, not the direction. That's good, because they didn't give me enough to give a direction, so I'll take that. If you did it this way, you would find that the acceleration equaled VF 25 minus VI 12 all over T. You would get 25 minus 12 divided by 8. You would get 1.625. You wouldn't round that off. And then you would go F equals 1,200 times 1.625. 1,200 times answer button. And you would, 1,200, Mr. Dewick.
No way.
All right, we're going to pause. And I made a mistake on my calculator, unfortunately, so let's retype it. 1,200 times 1.625, and you, wow, plus. Am I in a slump on my calculator or what, Mr. Dewick? Times. There's the 1950 that I was trying to get. So if you did it this way, I would probably go 1 mark for that, half mark for the numbers, half mark for the answer. I'd give you full marks if you did it this way as well. Ooh, they want me to find the change in velocity. What's the symbol for change in velocity? What's the symbol for change in? What's the symbol for velocity? I got on. You know what? I think I'm going to go like this. F delta T equals M delta V. Okay. How will I get the delta V by itself? How will I move the M over? I guess delta V is going to be F, 120, times T, 8, divided by 40. I can do that in my head. 24? Yes? No? What does that mean? It means that if we were originally going at 1 meter per second, our final velocity was 25. There's your change in velocity of 24. Or if if VI was 10, VF would be 34. Okay? You okay there? Yeah? Okay. The good news is we have another collision coming up soon. Okay. I would give you 1 mark for that, half mark for that, half mark for the answer. I see 2 masses in this question. I see the word collides. This is conservation of momentum. The sum of all the momentum beforehand equals the sum of all the momentum afterward. You know what? I'm gonna use G for George and J for Jim. I was going to label them A and B, but then I thought, why don't I use their first letter of their name? That's going to be easier to track. I see east, I see west, so I'm going to let east be positive. West is negative. Okay, I think we're good. Before the collision, we have mass George, velocity George initial, and mass Jim, velocity Jim initial. Bam! They collide. Nothing? Nothing. Okay. It looks like after the collision we have mass George, velocity George, final, and mass Jim, velocity Jim, final. What are they asking me to find? Dale, can I take the hoodie off just so I know you don't have headphones in? Thanks. What are they asking me to find? Okay. I guess this drops down. And I guess I would minus that and divide by, I guess that equals that. Okay. I got room? I got room. It's going to be, I have no idea. George, 65. East, 12. Plus Jim, 85. West, -4. Minus George, 65. 4 east, all over 85. Definitely brackets around the top. 65 times 12 plus 85 times -4 plus, no, not plus, Mr. Dewick, minus 65 times 4, close off the top, divided by 85. Do you get 2.11? 2.12? Direction. What if I asked you as a part B, hint, hint, to find Jim's impulse? Could you? Do I know force? Do I know time? Do I know Jim's final velocity? Oh, do I know his initial velocity? I can find his impulse. Or I can find George's impulse, which would be the same as Jim's impulse, but in opposite directions. Can anybody tell me why this question is impossible? Why is this question impossible in real life? So, they're coming towards each other, right? Let's use different objects, Mr. Duke. They're coming towards each other. They collide. How fast was George going after the collision? Magnitude and direction. 4. How fast is Jim going after the collision? Magnitude and direction.
2.
Did George go right through him? Is that possible? I made up some bad numbers on purpose just to let you know I will try and make these work out in real life, but if this was like a bullet and a target, that would work because a bullet can go through an object, but I don't think a hockey player goes through an object. I had somebody last year said, well, maybe Jim fell down and George kind of hopped over him and kept going. Okay, I've seen collisions that were like that too, but this is kind of some wonky numbers. So if you were wondering about that, if you spotted that and went, good eye on you, because I don't think this could happen in quote-unquote real life very easily. But I would give you still 4 credit. What was this? 3 marks? 1, 2, 3, 4, 5 lines. I'd probably go a half mark if I saw that. Half mark for that. Half mark for that. Half mark for that. And 1 mark for the answer. Can you give yourself a score, please, out of 14?